Okay, so in this video I'm going to have a look at uniform acceleration and deceleration questions. I'm going to have a look at two questions in particular. The first one will have mostly numbers in the question and a numerical answer. And the second question will have letters and numbers, and we'll have letters and numbers in the answers. So let's have a look at the first one. We have a car that accelerates at 2 meters per second squared and decelerates at 3 meters per second squared. Find the time it will take to travel a distance of 400 meters from rest to rest. And we're given two conditions. The first condition is that it is subject to a speed limit of 18 meters per second, and the second condition is where it is subject to no speed limit. So let's have a look at part 1. Now in part 1 here I've drawn a velocity time graph of what's happening, and you can see here that we've got velocity on the y-axis. We have a maximum speed limit here of 18 meters per second, and we can see the acceleration here of 2 and deceleration of 3 meters per second squared. So let's see, the total distance here as well, by the way, is 400 meters. So let's just break this up into 3 parts. So I'm going to break it up into this triangle here, this rectangle and triangle out here. So I'm going to call this time 1. This is time 2, and it takes time 3 to do the last triangle section here. So let's have a look at how we're going to work this. We've got to work out the time it will take to travel a distance of 400 meters from rest to rest. So the way we're going to do this is we're going to look at this equation here, v is equal to u plus at, or we can just simply look at the acceleration and deceleration lines here, this one and this one here. The slope of this line is 2, the slope of this line here is 3, or minus 3 in fact. But what we can do to find this 2 here is just get the tan of this angle, or the rise over run, or opposite over adjacent. So in other words, the slope of this line here is going to be this distance here, which is 18, divided by the run here, which is t1. So we can write that 2 is equal to 18 over t1, or we can just say then that t1 is equal to 18 over 2, or just 9 seconds. So we've worked out the time here, it's just 9 seconds. Let's do t3 then, same thing again. The 3, which is the acceleration, is going to be calculated using this equation up here, or by just calculating the slope of the line. So it's going to be 18 divided by t3. So 3 then is going to be equal to 18 divided by t3. So that will just give us t3 is equal to 18 divided by 3, which is 6 seconds. So the time out along here is 6 seconds. Okay, so let's have a look and see if we can work out t2 then. So what we're going to do to work out t2 is look at the area underneath the curve. So we're going to look at this area, and this area here, and add them up. So to find the area of a triangle is just half the base times the height. So our total distance of 400 meters is going to be equal to half of the base, which is 9, times the height, which is 18, plus the area of this rectangle here, which is just base times height. So that's t2 times 18, and then our triangle out at the end here again is half the base times the height, so it's half times 6 times the height, which is 18. So we have an equation here with just t is the variable, so we can just isolate t2. So let's see, what do we get? We get 400 meters out here. Half of 9 times 18 is 81. Here we've got 18 times t2, and out here we've got half of 6 times 18. That's 54. Let's just bring everything over to the left hand side except the 18t2, and we get 265. And then finally just divide by 18. That'll give us our t2 as 265 over 18, and that's seconds. Okay, so now we have our t2, so all we've got to do is work out our total time. So the total time is just equal to 9 seconds for the first triangle plus 265 over 18 for the rectangle in the middle, and then out at the end we had a triangle, and that was 6 seconds. When you add all those together, you get 535 over 18 seconds. And that's the first part of this question completed. That's where the car accelerates and then it travels at a constant speed of 18 meters per second because there was a speed limit, and then decelerates to rest. Okay, so this is part 2, and in this particular section we don't have a speed limit, so we don't know the maximum velocity. So in this case we're just going to use v, and we have an acceleration here of 2 meters per second squared and a deceleration of 3 meters per second squared. So what I'm going to do is just divide this into 2 triangles. I'm going to call this time 1 out to here, and this is going to be time 2. So what we're going to do is we're going to get time 1 and time 2 in terms of v. So let's do that. So we know that 2 is going to be equal to v over t1. So in other words, the slope here is going to be this here divided by this here. So v over t1. So that will just give me t1 then is going to be equal to v over 2. Let's do t2 then. So we know that 3 then is just going to be equal to v over t2, giving us t2 is equal to v over 3. Now let's look at our distance. The total distance is 400 meters. So we take 400 meters, or just 400, is equal to, we're going to look at the distance here and the distance here, which is the area underneath the curves, and add those two together. So the first distance is half the base times the height, so it's half of t1. Well, we know that t1 is just v over 2, and that's times v, which is the height, this height here. And then we're going to add half t2. Well, we know that t2 is v over 3. We've got to multiply that by v. So what we're going to do here is just simply solve for v. So we've got 400 is equal to v squared over 4 plus v squared over 6. Let's just add these fractions on the right hand side. So let's use 12. 4 into 12 is 3, so we've got 3v squared here. 6 into 12 is 2, so we've got 2v squared here. So that'll give us 400 is equal to 5v squared over 12. Let's multiply across by 12 and then divide by 5. So that'll give us 960 is equal to v squared, giving us a v then, just square root both sides, giving us a v of 8 root 15, and that's meters per second. So we just have to find the total time then. So our total time is just equal to t1 plus t2. In our case, t1 was v over 2, so that's just 8 root 15 divided by 2 plus 8 root 15. For t2, it was over 3. Just got to add those two together, and you get 20 root 15 over 3 seconds. And that's it for the second part of this question. This is the total time that it takes for the car to accelerate and decelerate over a distance of 400 meters without any speed limit. Okay, so this is the second question. We have a car which can move at acceleration 3a meters per second squared and deceleration 5a meters per second squared. Find the time taken to cover a distance of 90 ak squared meters from rest to rest. First of all, subject to a speed limit of 15 ak meters per second. So this is the diagram similar to the first one in the first question, but this time we have a speed limit of 15 ak. So this is 15 ak here. Again, I'm just going to divide this diagram up into 3 sections. So we have a triangle, a rectangle, and a triangle. So this is time 1, this is time 2, and this is time 3 here. So again, let's look at our times. So we're going to get our times in terms of k. So let's see, we have time 1, we look at first. So we know that 3a, the acceleration, is going to be equal to, again, rise over run if you like, or the slope, which is 15 ak divided by t1, or just t1 is equal to 15 ak over 3a, which is just 5k. So t1 is equal to 5k. Let's do the same for t3. So we know that 5a is going to be equal to 15 ak, so this distance here, divided by this distance here. So it's 15 ak divided by t3. That'll give us t3 is equal to 15 ak all divided by 5a. That'll finally just give us, let's see, we have t3 equal to 5 into 15, 3. The a's will cancel and you'll end up with k there. So we have t1 and t3 now, so let's look at t2. We've got to find t2. So we know our total distance is 90 ak squared. So we have 90 ak squared is equal to, again, let's look at our distances. So I'm going to look at this distance here, which is half the base times the height. So it's half of t1, but t1 is 5k. So I'm going to put 5k in here times the height, which is 15 ak, plus this one here is just going to be t2 times the height, length times width. So that's 15 ak. And then finally, we have our last triangle here, which is half the base times the height again. So it's going to be half of t3, but t3 is 3k, and then the height is 15 ak. So let's just work through this to find t2, or to get t2 on its own. So we've got 90 ak squared is equal to, this will all just simplify to 75 ak squared. 75 ak squared divided by 2. Here we've got 15 ak times t2, and out here then we have 45 ak squared, 45 ak squared over 2. Okay, so the next thing I'm going to do is just multiply everything by 2. So on the left hand side we'll get, let's see, 180 ak squared is equal to 75 ak squared plus 30 ak t2 plus 45 ak squared. Now what I'm going to do is just take this ak squared and this ak squared, bring them over to the left hand side. So subtract, that'll give me, let's see, 60 ak squared. And that's going to be equal to just 30 ak t2. And then finally just divide by 30 ak, which will give me t2 is equal to 2. The a's will cancel. The k will divide into k squared to give me k. So t2 is just equal to 2k. So our total time then is equal to t1 plus t2 plus t3. So t1 was 5k. T2 we've just worked out as 2k, and T3 was 3k. So our total time in this particular case is 10k seconds. Okay, so this is part 2 of this question. So let's see, I've drawn the diagram here. This is where there is no speed limit. So I put v here as the maximum speed that the car will do if it accelerates fully at 3a meters per second squared and decelerates at 5a meters per second squared. So again, what I'm going to do is just divide this up into two triangles. This is going to be T1 here and T2 here. So let's get T1 and T2 in terms of v, the same as we did in the first question. So let's see, we know that 3a then is going to be equal to v over T1, giving us T1 is equal to v over 3a. We know that 5a is going to be equal to v over T2, and that'll give us t2 then is equal to v over 5a. So let's put these together then. We know that the total distance is 90ak squared. So we got 90ak squared. The total distance is going to be equal to the total distance here and here. So the distance on the left hand side is half the base times the height. So that's half of t1, but t1 up here is v over 3a. So v over 3a, and then times the height. Well, the height is just v, plus again half the base times the height, half of t2. Well, t2 is v over 5a. So I'm going to put v over 5a here multiplied by v. Okay, so let's just simplify all of this. So we got 90ak squared is equal to, well, we'll have v squared on the top when we'll have 6a on the bottom. Here we'll have v squared on the top and we'll have 10a on the bottom. So let's see, we can add those two fractions on the right. 90ak squared is equal to, let's use 30, I think, 30a. So 6 into 30 is 5, so 5v squared up here. 10 into 30 is 3, so it's 3v squared here. That'll give us, let's see, 90ak squared is equal to 8v squared over 30a. Okay, so the next thing I'm going to do is I'm just going to multiply both sides by 30a. So multiply the left hand side by 30a, that'll give me 2700 a squared k squared, and that's equal to 8v squared. Divide both sides by 8, that'll give me a v squared on the right hand side anyway, and on the left hand side I'll get 675 over 2, and I've got a squared k squared. So now what I've got to do is square root both sides. So square root the right hand side will finally give me v, and on the left hand side I will get 15 root 6 over 2 a k. Okay, so now I've got v, so let's work out our total time then. So the total time is t1 plus t2. Now t1 then was v over 3a, so our t1 is v over 3a, so it's 15 root 6 over 2ak divided by 3a. t2 is v over 5a, so that's 15 root 6 over 2ak all over 5a. So let's just divide all this up. So let's see, we have the a's will cancel anyway, and we just have to divide 3 into this here. Well, if we do that, we'll get 5 root 6 over 2, and we have k there as well. And now we just got to do this bit here. So when you do that on your calculator, you'll get 3 root 6 over 2 times k. Now if you add those two fractions, this one and this one here, we've got k's out here, so you can just add these two fractions. You will get 4 root 6 times k, and this is seconds. So this is the time it would take to accelerate at 3a meters per second squared and decelerate at 5a meters per second squared with no speed limit. Okay, so I've done two questions. One was a fairly straightforward one. It involved only numbers. The second one involved numbers and letters, a little bit more intricate, but the two procedures are exactly the same.